All right, welcome to the second section of Chapter 9. Today we're going to talk about parabolas, and you might be thinking that we have already talked about parabolas this year, which we have, but we're going to delve a little bit more into the vertex form of parabolas and talk about parabolas that open vertically and horizontally, and some of the very specific vocabulary and characteristics of parabolas. So there's a lot of new vocabulary to focus on in this section, so as you go through, make sure you check off that you understand what each of these words are as we come to them. Remember that in general, this is the form of a parabola, one of the forms that we learned back in first semester. This is called the general form of a parabola, ax squared plus bx plus c. A parabola is one of the conic sections we talked about last time. But another definition of a parabola, which is what we're focusing on in this chapter, is that technically a parabola is all the points in a plane that are the same distance from some point, which is called the focus, and a given line, which is called the directrix. So if you look here at this graph, the blue curve is the parabola. This point right here is the focus, and this line down here, this green line, is called the directrix. Every point on this parabola, so if we look at this point right here, is the same distance from the directrix as it is from this point called the focus. Okay, so the focus is on the axis of symmetry, but it's different from the vertex. So the vertex is here, the focus is a little bit above it. All the points on the parabola are the exact same distance from the focus as they are from the directrix. Okay, so my axis of symmetry is still x equals h. Remember, h is the x-coordinate of the vertex, k is the y-coordinate of the vertex. And then my a value of my parabola has to do with where my focus is and where my directrix is. So my focus is h, so I have the same x value, and then the k, the y value, is moved up by a value of 1 over 4a. So it's 1 over 4a above my vertex. And the directrix, which is, notice this is an equation, y equals some number because it's a horizontal line, is 1 over 4a units below the vertex. Okay, then we have something called the lattice rectum, which is a line segment that goes through the focus and is perpendicular to my axis of symmetry. So standard form for a parabola is what we called vertex form back in first semester. Y equals a, there's my a value, times the quantity x minus h squared plus k. These are the normal parabolas we're used to seeing that open up or down. A little bit later in this section, we'll talk about parabolas that open right or left, and their standard form looks like this. It's x equals. So remember, if a is greater than 0, my parabola gets narrower and it opens up. So it's vertically stretched up. If a is less than 0, it gets wider, so it's a vertical compression, and it opens down. Actually, sorry, scratch that about narrow and wide. That doesn't have to do with the positive or negative. Just if a is positive, it opens up, and if a is negative, my parabola opens down. And then a, whether it's larger than 1 or between 0 and 1, not talking about the negative, depends if there's a vertical stretch or a vertical compression. All right, so in this chapter, I will give you this chart on your quizzes and tests. My goal for you in this chapter is to be able to use these different formulas. Okay, so here we have two kinds of parabolas. This is the one we've seen before. These are the ones that open up or down. These in the right-hand column are my horizontal parabolas that open to the right or open to the left. Okay, so the vertex of both of them is hk, coming from this standard form. The axis of symmetry is a vertical line if my parabola opens up or down, and it's a horizontal line if my parabola opens left or right. And then you can see the equations for the focus, the directrix, and how long the lattice rectum is. And we will be using those. Again, my goal is for you to be able to take this chart and apply it to your examples. So let's take a look at the first example. We're going to write this equation. This is an equation in general form. We're going to write it in standard form. And we're going to find the vertex, the axis of symmetry, and the direction that it opens. So in order to write this in standard form, we are going to have to complete the square. So we're going back to some stuff that we did in first semester. Remember, to complete the square, we always factor out any coefficient of x squared. So here we factor out a -1, but we leave the constant by itself. In first semester, I usually had you guys move the constant to the other side before you started, just so that you didn't mix it up. But the book leaves it on the right-hand side. You can move it to the left. So here I factored a -1 out of the x squared and the 2x. And then remember, I have to take half of b quantity squared. So half of b here, 1/2 times b squared. I'm going to do 1/2. My b value right here is 2. And so that's 1 squared, which is 1. So I'm going to add a 1 inside my parentheses here. That 1, remember, is actually a -1 because it's multiplied by this -1 in front. So that's really like subtracting 1. So if I'm going to do my work on the same side, I have to add 1, right? So I have to, if I'm subtracting a 1 here, I have to add a 1 here. That's sometimes why it's easier to have the 3 instead of having it over here, to have it on the left-hand side. But either way, remember that the reason that we do that is because this is now a perfect square, x plus 1 quantity squared. So my equation looks like this. And I can read the vertex and everything I need to from here. So my vertex is h, k. Remember here, the equation is x minus h. So this is, if this is a plus, I have to take the opposite. So my vertex is -1, +4. My axis of symmetry, this is a vertically opening parabola. It actually opens down. So that means my axis of symmetry is a vertical line, x equals -1. Okay? So I want you guys to try that with this example. All right, you should have gotten C. And here's the work for that. Notice in this one I decided to take my +5 and just move it over here to the left until the very end. I think that's easier. So I factored out the 2, and then half of this 2 squared is 1, so I add a 1 here, but remember this 1 is being multiplied by 2, so it's like adding a 2. So I have to add a 2 on the left side, rewrite this as a square, move my 3 back over to the right, and now I have standard form. The vertex here would be -1, 3. My axis of symmetry would be x equals -1, and this parabola would open up because my a value is positive. All right, graphing parabolas, again, thinking back to first semester. Remember that when I have my equation written in standard form, this h is a horizontal translation, just like we've been looking at with all of our functions, and this k is a vertical translation, and a is a dilation, and it can also reflect depending on if it's negative or positive. So we're going to graph y equals 2x squared. In this equation, if I were to try to write it so it looked a little bit more like vertex form, it would look like this, right? X minus 0 quantity squared plus 0. So I can see that the vertex is at 0, 0, or at the origin. X equals 0 is my axis of symmetry. And then I can just plug in some easy values of x. If I plug in 1, I get 2. If I plug in 2, I get 8. And 3, I get 18. Remember that my graph is symmetric around the axis of symmetry, which in this case is the y-axis. So the points on the opposite side, -1, 2, -2, 8, and -3, 18, are also points on my graph. And then I just draw my graph. So here's 0, 0. Here's the point 1, 2, -1, 2, and so on. All right, if I'm going to graph this one, this is a little more easy to recognize as far as standard form goes, or vertex form. So in this case, h is 1 and k is -5. That means my vertex is 1, -5. So my vertex moved to the right 1 and down 5, and I have a vertical stretch of 2, which is the same as the vertical stretch I had in my first example. So basically my vertex moved from 0, 0 to 1, -5. And all of the other points, remember I had the point 1, 2, that also moved to the right 1 and down 5. And I was able to just translate all of my points like that to get this graph from the first one. Okay, so you guys try this one. Which graph do you think it is? Okay, hopefully you said B. You should notice that this parabola opens down, so A and C were automatically out. Vertex is at 0, 0, and then you just plug in some points to see what's happening. If I plug in 1, I get -3. -1 also gives me -3. All right, try this one then, a translation of that first graph. Okay, in this case, we end up with A. My vertex moved from 0, 0 to -1, +3, still opening down. So I was shifted to the left 1 and up 3, which we can see is happening in part A. All right, we're going to see how much farther we can get here in this video. All right, vertically opening parabolas, or parabolas with vertical axes of symmetry, have the parent function y equals x squared. And they look like this, right? These are the ones we're used to. I can also have equations of parabolas that have horizontal axes of symmetry. They have the parent, this shouldn't say function, this should say parent equation, x equals y squared. So notice if it opens left or right, the y is squared and the x is by itself. These are not functions because if I draw a vertical line, it'll cross it twice. So they're just equations. And they look like this. I still have h and k, but notice that h and k are in different spots. The k, which is the y value of the vertex, is with the y, and the h, which is the x value, is added out here. So those kind of get flip-flopped because x and y get flip-flopped. Okay, so we're going to take a look at this example and see how far we can get. So notice here x is by itself, and the y is squared. So that automatically tells me it's going to be a sideways parabola, or a parabola that opens left or right. So I'm going to get x by itself. Here's my original equation. I'm going to move everything to the other side, and now I'm going to complete the square just like we did before. So let me show you how that looks. So hopefully you can follow this process. I decided to write it out for you because I showed you how I moved the 1 over to the left-hand side. I factored the negative out of these two terms, completed the square, so I added a 4 on this side, but it's really a -4 because it's multiplied by the negative, so I subtract 4 on the other side. Simplify, rewrite it as a perfect square, and then move the 3 back over. So this is my standard form. So here's my standard form. That means my vertex is 3, 2. Remember that when it's x equals and the y is squared, my x value is out here and my y value is in here. So my vertex is 3, 2. Axis of symmetry is now a horizontal line, so it's y equals 2. The focus, which you get the equation from looking at that chart from the beginning. In my focus, I have to take the x value of the vertex and add 1 over 4 times a, and then the y value stays the same here. So that simplifies to 11/4, 2. That's my focus. And this is my directrix. So x equals, because it's a vertical line for a horizontal parabola, 3 minus -1/4, which is 3 1/4. And it opens left because a is less than 0. So when a is less than 0, my parabola will look like this. It will open to the left. And then I can use the formula from that chart to find the length of the lattice rectum. So take a look at all of that information here. Here's my vertex. Here is my focus. My directrix is a vertical line that we draw in as a dashed line, and here is my axis of symmetry. And then I graph my parabola. I plug in a few points and just draw the graph. So I want you guys to identify which graph matches this equation. A is our answer. All right, and here's the work to show you how to complete the square. This one was a little easier because I didn't have to factor anything out of my y squared plus 6y. I end up with a vertex of -7, -3. And because a is +1 here, I know it opens to the right, and that's enough information to answer this question. Okay, so for this last one, I'm given the vertex of a parabola and the focus, and I want to write the equation. Since my vertex is 8, 6, I know that h is 8, and k is 6. I'm going to use the focus to solve for a. So this is the equation of my focus, x equals h plus 1 over 4a. Notice I know this is going to be a horizontally opening parabola if I just think about where the vertex and the focus are. So if my vertex is here and my focus is directly to the left, it's actually going to open to the left. So I make sure I use the correct equation. I know my h is 8 and x is 2, because I get that from the focus. And then I just solve for a. And I get -1/24. and I just plug that into the equation of my parabola and use that to graph. We'll practice more tomorrow.